All right, so we're going over chapter 17, which is the language of hypothesis testing. Okay. Now let me give you. Let me turn this out. Hopefully that will stay focused. Focus. Focus, I say. There we go. Now it's focusing. All right. So let me. Let's do an example. You and a friend flip a coin. Heads, you win. The coin comes up. Tail, 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 tail. First of all, well, let me do this question first. What is the probability of 5 tails in a row? Is this evidence your friend is cheating? Okay. All right, so we could actually figure this out. I wonder if you guys can figure that out. What would be the probability of the first tail?
1 out of 2.
1 out of 2, right? What's the probability of the second tail?
1 out of 2.
Also 1 out of 2. Third tail.
1 out of 2.
Okay. Somebody decided to add the fourth tail. Oh, thank you, Kara. And finally,
My name's Emma.
I said Abby.
Yeah, and you said thank you, Kara. My name's Emma.
She said Kara. Kara answered, didn't you?
No, I ain't.
Oh, I saw her lips move.
No, when I was voicing for her.
Okay. Finally, last one, Emma.
1 out of 2.
1 out of 2, thank you. Okay, so that would be 1 out of 32, right? Now,
Wait, 1 out of 32, where did you that?
what's 2 times 2?
Oh, you multiply it.
Yeah. So 1 out of 32, how often does that happen? What's the percentage on that? Let's get a calculator. Are we all asleep today, or is it just me?
It's 0.03125.
0.013, no, 0.03.
Yeah, 0.03125.
125. Okay? So, 0.03. So about 3% of the time. Okay? Now, is that unusual? It is unusual, right? Is this evidence of your friend cheating?
No.
No. Not that alone.
What do we say normally? Let's assume our alpha, what's our normal alpha? To assume
0.5.
0.05, right? Okay, so if you had $100 on this coin flip and it came up tails 5 times in a row, would you think your friend was cheating? You'd probably be more likely if it was $100 on your coin flip, right? Okay. So the idea here is, could it come up 5 times in a row? Yes, it could. But if we're using this as our cutoff, we're going to say, yes, your friend's probably cheating if that's it. This only happens 3 out of 100 times. Okay? So the idea here is how this is the question. How do you decide? Okay? And we're going to decide based on our alpha. Okay? Typically, if I don't give you an alpha, what should you assume? 0.05. You're going to be right 95 times out of 100. Right? Okay? You're going to be wrong 5 times out of 100. Okay? So you may incorrectly accuse your friend of cheating when they weren't cheating, because it will happen 3% of the time, but you're going to be right most of the time.
So anything less than the 0.05?
So anything less than 0.05, we will call, this is what we would say is statistically significant. Okay, now you can choose any alpha that you want. Now your sample size is pretty small, right? 5 flips. Would that be big enough?
No.
No. Okay. All right. How big should your sample size be for a coin flip? We know Adam wants to give all the answers, but the rest of you need to wake up too. Okay. Now, just as a reminder, 2 things. Class just got hard today. Okay. Number 2. Yeah, I know from here on it's going to get really hard. So it's going to be very important that you're doing your homework and staying up with this, because this is the hard stuff. Okay. Number 2, all of this stuff that we're going to be learning today is going to relate, but this would directly relate to your final project. Okay. Your final projects are going to be related to not only confidence intervals, but hypothesis tests as well. Okay. So make sure you learn this really well, and you've been collecting your data. All right. So the idea here is, I think I do want to give you this. Okay. Here's what I would like, and I almost feel like I should supplement some of these problems. I'm going to give you 7 steps for a hypothesis test. Okay? Now, in one sense, even if the question doesn't ask you to go through these 7 steps, you should go through them all anyway. Sometimes there might not be enough information to do the problem. In fact, in chapter 17, I'm kind of jumping the gun a little bit. This is going to be more of chapter 20. We're going to concentrate on step number, I think, 4. So let me give you the 7 steps. Actually, sometimes I do 8. Make sure I'm on here. Oh, let's start with 7. Okay. Step number 1: list all the important numbers. Okay. We've kind of done that. And by the way, this also works for confidence intervals too. Okay. Hypothesis tests and confidence intervals are 2 different methods to do basically the same thing. Okay. And so this works for that as well. Okay. Oops. All right, step number 2. Hopefully this will focus. Oh my goodness, why does this thing go out of focus all the time? Focus, I say. Oh my goodness, it's horribly out of focus. I don't know why. All right, you'll just have to hear it because I can't read. Now you're going to ask yourself the question: is the data quantitative or categorical. Okay? The answer to that question is going to affect the rest of the steps. I don't know why this is so bad on focusing. It will not focus. Sorry. Number 3. Find the null and the alternative hypothesis. Okay, now chapter 17 is going to focus mostly on step 3. Oh, now it's focused. Okay, now let's define what is a null hypothesis. Okay, a null hypothesis is a mathematical statement that means no change, no difference, or in this case, a fair coin. Okay? And I'm going to add some rules here. It's always about the population. And then underline population. Okay? Part B, it always has an equal sign. Part C, it's represented by H sub 0. And part D, it's often not stated directly in the problem. Okay? Now, because it's not stated directly, a lot of you mix it up with what we call the alternative hypothesis. Alternative hypothesis, which is a statement we are trying to prove. Okay? And it's often represented as either H sub 1 or H sub A. Depending on the book, some people like H sub 1, some people like H sub A. I don't care. You can use either one, and it doesn't matter. There's nothing special about it. It's just either H sub 1 or H alternative. Okay? And B, this is often stated in the problem. Okay? And because it's often stated, this is why people almost always identify the alternative, but sometimes they call it the null. But remember, the null is usually not stated. Sometimes it is, but it's often not stated. Yes?
The statement we
are trying to create. All right. Now, part of me wants to give you all the steps. I think I will. Let me just focus on, your homework's going to probably focus on the first 3 steps, okay? But I want you guys to kind of know where we're going with this, and so I'm going to give you the rest of the steps, which is step number 4 is to pick the correct test, okay? All right, now I'm going to give you this hopefully this will be a good outline for the rest of the semester. In fact, you're going to be using this probably for the rest of the semester. Okay? Now, back on step number 2, we asked, is your data quantitative or categorical? The answer to that question is going to be used in step number 4 if your data are quantitative. Then there are 2 possible tests, okay? And I'm going to give you those answers, okay? The next one is you need to say, it's a one sample mean. I'll go give myself more room. So one sample mean and the population standard deviation is known. Then it's a z-test. Okay? If it's quantitative is yes, then a one sample mean and population standard deviation unknown, then it's going to be what's called a t-test, which I haven't taught you yet. I'm just preparing you for that. Okay? All right, so this is if it's quantitative. If it's categorical, if categorical is yes, then it could be one of 2 tests. It's a one sample proportion, which is also a z-test. It's going to be a different equation than it is here, okay? And it could be an independence test, independence. And in that case, it will be a chi-square test. That looks like an X, but it's actually the Greek letter chi. It's kind of the script X, okay? Step number 5 is to find the p-value, which you've done plenty of times in class. Then we're going to go to step number 6, to decide to reject or not reject. And I'll give you a nice little phrase for that later. Step number 7 is to write the conclusion in English, not statistician. Okay? We'll concentrate more on those last steps. It's not going to be in this section. But what I would like you to do, if you guys, I know some of you are taking pictures, this is a great board to take a picture of, because essentially what we're going to be doing for the rest of this semester, we're going to use this outline pretty much every day in class from now on. Okay? In fact, I may post my notes up here, and you can use that again. Okay? So in the one sense, this is going to get very repetitive, this class, and I hope that the repetition is good because, well, sorry. Step number 3 can be hard. Step number 4 can be really hard. In fact, 4 is probably the hardest step. If you get 3 and 4 wrong, you're screwed. Okay? You can still get points here, but steps 3 and 4, actually, some of these you're going to find are very, very difficult. So here's what I would like to do. I guess, here's what we'll do. We're going to concentrate mostly on steps number 1, 2, and 3 today. That's what chapter 17 homework is on, and I hope It's pretty easy. And so what I'd like to do, I'm going to leave most of this here, and we're going to concentrate on the first 3 steps. And I'm going to go over some examples, and I'm hoping that this won't be too bad. All right.
It was kind of blurry.
Okay, let's do an example here. Okay. A pharmaceutical company has developed a new antibiotic for children. Other antibiotics show 2% of children get a headache as a side effect. FDA wants to know if the new antibiotic is more than 2%. Find null, the alternative hypothesis. Okay? All right, so let's go through these first 3 steps here. And let's make sure we're most concerned about step number 3, but I think it'll be good practice to go through here. And we're going to list all the important numbers. Pharmaceutical company has developed a new antibiotic for children. Other antibiotics show 2% of children have headache as a side effect. Okay? So 2% sounds like that's an important number, right? So list all the important numbers. Something equals 2% or 0.02. What is the something? Okay? This is where it's going to be important for you to identify letters. Okay? What letter is 2%? Is it mu? Okay, now let's review. What does mu represent? Population what? Mean. Okay, is this a mean? No? What do you think?
Sample.
It is a population, but it's not a mean.
Standard deviation.
Is it a standard deviation? Okay. In order to help you answer that, let's go to question 2. Are the data quantitative or categorical? Quantitative. Quantitative because
it's a number. That's 2%.
okay. Can you use numbers with categorical data?
No.
Yes, you can. Okay. Now, what are we measuring here? Step number 1's already hard to tell. What are we measuring? Say it again.
Huh?
What did you say?
I'm trying to figure out the problem. I don't know.
What does the FDA want to know about? Side effects, and specifically headaches, right? So, child either has a headache or does not have a headache. Okay? Is that categorical or quantitative? What'd you say?
Sounds like categorical.
It's categorical. So answer number 2 is categorical. Maybe these don't always have to be in order. Maybe we should have done category 2 first, or step number 2 first. Your data are categorical. The categories are headache, no headache. Okay? Because it's categorical, I'm not going to be using you. What other letter can I use?
Alpha.
No, alpha. Alphas are significance level. We can list our alpha though. We'll do alpha in a minute though. We need to know what that is. Okay? We're going to use P. P for proportion. What are the proportion of children who get a headache? Okay? And it is a population. So P is the letter we're going to use for population proportion. Okay? Does that make sense? We'll be really picky about notation here, because if you can get the notation right, it's going to make step number 4 a whole lot easier.
Were we supposed to know that P? Have we ever done that?
We've been talking about proportions. Have we ever talked about that? Okay. So yes, we're looking for P proportions. Okay. All right. Now, FDA wants to know if the new antibiotic is more than 2%. There's no new information there. That's going to be an important thing next, right? Find the null and the alternative hypothesis. Okay. So there's not nearly enough information to solve this problem. But we have identified that P is 0.02. We have now identified that it's categorical. Step number 3. Oh, what's my alpha? 0.05. Why? Because I didn't tell you. So if I don't tell you, it's 0.05. Okay? Now, step number 3 says to find the null and the alternative hypothesis. So when I ask for that, just H sub 0, H sub 1, or H sub A, I don't care. Okay? I'll probably flip them around just to be fun. Okay? Now, let's review here the null hypothesis. Oh, I didn't realize I wasn't recording any of that. Okay, you guys are supposed to be my eyes on my camera.
We're not worried about the video.
Oh, yeah. Brad, did you want me to record these videos?
That's funny. Yeah, I did.
Okay, good. So you need to be my eyes. Because I did ask before you showed up, so does anybody care? Because you can't see the computer anyway, and nobody cared. And I'm like, well, Bradley might.
Yeah,
Okay.
I did say that. Sorry.
All right. So let's talk a little bit about the null hypothesis here. Just as a quick reminder. Okay? Null hypothesis is a mathematical statement that means no change, no difference, or fair coin. It's always about the population. It always has an equal sign. It's represented by H sub 0, and it's often not stated directly in the problem. Okay? So in this problem, what is a statement about the population? It's always going to have an equal sign in it. And it's no change and no difference. Can't look at step number 1.
Is it 0.02?
What's 0.02?
Other antibiotic.
That's only half credit. What letter do I use? E. Okay? So we're saying essentially that the new antibiotic has no change than the other ones. Okay? Does that make sense? So the new antibiotic is exactly the same as all the other ones. What does the FDA want to know?
That's true. If it is one.
They want to know if it's more. So how would I represent that as more?
If P is greater than.
P is greater than 0.02. Okay? Now, just as a reminder here, the alternative hypothesis is stated in the problem. Okay? Often stated in the problem. Is the null hypothesis stated directly in the problem?
Is it, because it says other analytic percentage?
Yeah, I guess you could kind of go with that, but it's not stated very strongly. It's not stated nearly as strongly as the alternative hypothesis is. Okay? All right, so this is what we would call a one-tailed test. Okay? All right.
But what did you say the alternative hypothesis was?
This is your null and your alternative right there. P equals 0.02 versus P is greater than 0.02. Does that make sense? Okay, let me do one more example. I'm going to have to hurry on this one. Okay, so I'm going to just erase this. Okay. Blue book of 3-year-old Chevy Corvette is $37,500. Grant wants to know if price is different in Miami. Okay?
As opposed to where?
As opposed to here. Okay? So list all the important numbers. What are the important numbers?
$37,500.
Something equals 37,500. What letter am I going to use for that?
Quantitative, it's quantitative.
It's a quantitative number.
100%.
So you already answered step number 2. It's quantitative.
Mu
Is it mu? Why would it be mu?
for population.
Not just population, that's only half, right? Population mean, right? Okay. Grant wants to know, so what's my alpha? 0.05 didn't state it. Okay. Grant wants to know if the price is different in Miami. Okay, what's your null hypothesis?
Mu equals 37,500.
Mu equals 37,500. Your alternative hypothesis. What does different mean?
It means it has a less than.
We don't know if it's higher or lower, do we? Okay, so what should the alternative hypothesis be? Last time it was clearly greater than. What do we use when we don't know if it's greater than or less than?
Oh.
What not equal to, right? What's not equal to what?
Mu is not greater, is not equal to.
Mu is not equal to 37,500. This is what we're going to call a two-tailed test. Okay? When you're drawing your picture, in this case, we know that the mean is 37,500, right? But we don't know if we're going to use the right tail or the left tail. Okay? It's going to be a two-tailed test. Okay? We're going to use that information for step number 5 later on. Okay? So your homework is going to focus mainly on these first 3 steps. Okay? We're going to talk about psychology. I think you have enough set of questions make homework do. The quiz on Wednesday is gonna be on this stuff that we've covered. There's a little bit more. Maybe I'll make your homework due on Friday. How's that? Okay? We'll probably start 17 and go into 20 next time. Okay? So see you all on Wednesday, and make sure that you start to collect your data if you haven't already started. See you all on Wednesday.
You need to weigh potatoes
Thanks.
in all of them. So we